Hello everyone, this is Siddharth here. Today we'll be discussing add one row to tree question. Today's LeetCode daily challenge. In this question, we are given root of a binary tree and two integer values, value and depth. What we are asked is we need to go to that specific depth, considering that our root node's depth is 1. We need to go to that specific depth and we need to add a whole new row consisting of new nodes with a specific given value. In this case, that given value is 1. So what we ask is we need to add a whole new row at a depth 2. So we can see that we have added new nodes at our given depth. And another condition that we provided with is that all the left subnodes of the nodes present in the row before will be the left subnodes of the new nodes. This might sound confusing, but I'll make it a bit more clear. And the right subnodes of our previous nodes will also form the right subnodes of the new formed nodes. So let's consider an example. So in this example, we are considering a binary tree where the given root nodes value 1, and these are the depths of the specific rows in a sense. So my root node, the place where my root node stands, that is at a depth of 1. Now my second row is at a depth of 2, and similarly my third row is at a depth of 3. So in my case, I am asked to add a whole new row at a depth of 2, and what I need to do is I need to add all the nodes with a value 1. So my final result should look something like this. As we can see that I am now at a given depth of 2 when I consider this specific row. So I'll update my depth of my given rows as well. So this row will have a depth of 1, this will have a depth of 2, 3 and 4 similarly. Also the changing of subtrees in the sense that this very node's left subtree will be my new node's left subtree, my left new node's left subtree, and this very subtree will be my rightmost new node's right child subtree in a sense. So yeah, so clearly I need to take care of all the nodes present in the row prior to my given depth. So in this case, I am asked to add elements at a depth of 2. So what I need to do is I need to take care of all the elements present at a depth of 1. In my case, there is only one element, that being my root element. So I need to have a data structure in which I can keep all my last rows nodes. Why do I need to keep my last rows nodes? Because, and last row, when I say last row, I meant d minus 1. So I need to go to my d minus 1th row and I need to take care of all those elements present in that row. So yeah, after taking care of all those elements, in a sense I will keep a record of all the elements present in that row, and what I'll do is I will iterate through all of them one by one, and what I'll do is I will add new left and right child or subtree, or you can say nodes in a sense, because I'll be adding nodes first and then I'll attach the actual subtrees to the respective children's left and right subchilds. Alright, if that makes sense. And my data structure can be that of a queue because I'll be using breadth first search instead of a DFS. You can use a DFS as well, but to make it a bit more clear, I'll go with breadth first search. So let's take this very example and let's see how that will pan out. So first of all, my pointer will be pointing towards my root node. I'll check what my depth is. Clearly my depth is equals to d minus 1, which in our case is 1, and my current depth is 1 as well. So I'll stop right here. Of course I would have added my node into the queue before it, and after that, after I'm done with this, what I need to do is I need to take out all the elements from my queue one by one. So we are aware that queue follows a fashion of FIFO, that is first in first out. So 1 being my first element, it will get out first, and of course there are no other elements behind it, so that's fine either way. So what I'll do now is I'll take out my element from my queue one by one, and as soon as we pop our first element, we have 1. What we'll do is we'll take care of its left and right subtrees. In a sense, we'll have pointers which will be pointing towards its original left and right subtrees. So this will take care of my node's actual left, and right will store my node's actual right. So after I'll be done with this, what I'll do is I will have 2 new nodes formed here, and we'll fill them up with the value 1. And what I'll do now is I will assign my nodes left pointer to point towards my new given nodes. So this will look something like this now, and what I can do is I can make my new left nodes left pointer point towards my given left pointer, and what I can do is I can make my right nodes, my new right nodes, right pointer point towards my right pointer. So in this way, what I'll manage to do is I'll manage to have, in this diagram, I'll manage to have my new nodes left pointer point towards my original left subtree, and my right nodes, my new right nodes, right pointer will point towards my original right subtree. So that way we can solve this problem easily. Another thing to notice here is that we'll have an edge case where the value of d will be 1. In that case, so in this example, if my depth is 1 and the value that I need to insert is 0, what I need to do is I need to create a new node with the value 0 or whatever value that will be provided with, and we just need to make its left pointer point towards our root node. That will be it. So that's how we can handle this edge case. Now let's go back to coding. So first we'll be handling our edge case, that is if our depth is equals to 1, then what we'll do is we'll just directly create a new node, and we'll be assigning our value val to it, and what we'll do is we'll just have its left pointer point towards root node, and we'll just return add. So after dealing with our edge case, what we need to have is, first of all, we need to have our data structure queue, Also, just to keep a track of which depth we currently are at, I can store pairs. It's not necessarily needed, but to have a better understanding, I'm just using a pair to keep track of my depth as well. And what I need to do now is I need to push my root value and my current depth in my queue, and I just need to iterate through my queue until and unless it's empty. So one thing I need to make sure is that I don't actually get to a point where my current depth is equals to my required depth, so I can take care of that in a way that I can actually have another variable I which is equals to 1 in the very beginning. I need to check if when I'm incrementing my I, it is actually lesser than my depth value. So in this very case, in this very example, if I had the value of depth as 2 and my current depth value is 1, so if I'm already incrementing it by using this operator, so in that case I will understand that since plus plus I will equate to 2, I will know that I need to stop right here and I don't need to consider anything else. If that's not the case, what I need to do is I need to iterate, or I need to go through my current queue's elements. I can do that in a way as first of all I need to take care of the size of my queue. After doing that, all I need to do is I need to so what I'm doing here is I'm iterating through my given queue data structure, and as I'm doing it I'm also popping out those very elements. I know if my iterator is pointing towards the front of the queue, then the very first value the iterator would be pointing towards, its first value would be a node and its second value would be a level. So what I need to do here is that I need to check if this very node has a left child or not. If so, then I need to just push it. I'll do the similar thing with the right node. So after I'm done doing that, I need to go through all the elements present in my queue, and what I need to do is I need to I just need to have 2 pointers that will actually take care of the actual left subtree, and similarly another pointer to take care of the actual right subtree. Now I will have a new node that I'll be adding, onto my given node. Actually, not just one node, I'll be adding two new nodes. So that can be done as and I just need to make my nodes left pointer point towards my add one node, and my nodes right pointer needs points towards my add two node, and my add one's left pointer needs to point towards the actual left subtree, and my add two's right pointer needs to point towards my actual right subtree. So after I'm done doing that, I just need to return the root, and I believe this should be it. Okay, so I'm not actually popping these out. Okay, now it's working fine. Let's see if it runs. Alright, it's running perfectly fine, and that's right about it. If I were to talk about the space complexity of the solution, then we are adding new nodes first of all. So we are coming up with a whole row of new nodes, so that can have a constant space complexity of its own. And we are using a queue data structure that again will also not have a size of equating to n, where n is the total number of nodes, because we are not forming a queue, or we are not considering all the nodes. That would be considered in a worst case, where the depth is actually one more than the height of a given binary tree. So yeah, that's about it. And yeah, our time complexity would definitely be somewhere about the size of our queue data structure, and we are iterating through our given size, our final size twice. So yeah, that would just make it somewhere around, I guess, let's consider it to be order of n itself. So yeah, that's right about it. And yeah, I hope you guys liked the solution. If you did, please like and subscribe. And if you think that it requires, or the solution requires, any change, then I'll be glad to hear from you guys. And yeah, I'll catch you in the next one.